All right, on this problem, they've given us 4 separate unrelated math problems. Let's take a look at the first one. There are 2 challenges in this problem. One is that they're asking us to compute a secant, and the second challenge is that we have this strange-looking arc, negative 17 pi over 6. First comment here would be that in order to compute the secant, I'm going to need the cosine to do that, since they're the reciprocals of each other. So let's first focus on the cosine of negative 17 pi over 6. So where is negative 17 pi over 6 on our unit circle? Well, let's think about it. Negative angles go clockwise. Look at the diagram. Here's 0. Here's negative pi over 6. And if we continue to count by pi over 6 multiples, that would be negative 2 pi over 6, negative 3 pi over 6, etc., etc., etc. There's negative 6 pi over 6, which is equivalent to negative pi, negative 7 pi over 6, and so on. Let's continue to count. Negative 8 pi over 6, negative 9 pi over 6, negative 10 pi over 6, negative 11 pi over 6, negative 12 pi over 6, negative 13 pi over 6, negative 14 pi over 6, negative 15 pi over 6, negative 16 pi over 6, and finally, negative 17 pi over 6 would terminate here, in the same place as a more familiar angle, positive 7 pi over 6. But that's where that angle terminates, and we know the cosine of that is negative radical 3 over 2. That's just from the unit circle. Now that I have the cosine, let's recall that the secant is the reciprocal of the cosine, and substituting what I know the cosine to be and doing some basic algebra will get me the answer to this first of 4 problems. Let's go on to our second problem. This problem is relatively straightforward because based on our unit circle knowledge, we know that the cosine of pi over 6 is radical 3 over 2. Now I simply did PEMDAS. 4 times that fraction. Here, it's worth noting that while exponents generally don't distribute, they do distribute to a product, and this is 2 times radical 3. Therefore, I can essentially square both of the factors in that product, which leads me to an answer of 12. Let's take a look at our third problem. This problem is interesting because pi over 9 is does not terminate at one of our favorite 16 points on the unit circle. But nonetheless, I can still compute this value by simply noting that the cosecant of pi over 9 is the reciprocal of the sine of pi over 9. And whatever the sine of pi over 9 is, I don't know what it is, but whatever it is, when you divide it by itself, you get 1. And lastly, let's take a look here. This is an interesting problem because the cosine of 3 pi over 8 is not something that we can do without a calculator. And therefore, there's no way for us to find that value and then square it, at least without a calculator or some other fancy methods. So if we can't compute the cosine of 3 pi over 8, how might we proceed in this problem? Well, here's a cool trick. Remember this identity? Doesn't the right side of that kind of look like the problem we're doing? This is one of these problems where you just had to have this flash of insight like, hey, that looks like an identity I know. In fact, let me take that identity, look at the right side of your screen. Let me take that identity and reverse it around, which might suit our needs a little bit better on this problem, just the way it's presented. If this is true for any value of theta, then it's specifically true when theta is 3 pi over 8. So substituting 3 pi over 8 in for theta gives me this. Now look at the bottom equation. The left side is the one I want the answer to, but can't compute directly. The right side, which is equal to the left side, is something I can compute. So by computing the right side, I am computing the left side. The right side can be computed directly because While 3 pi over 8 may not terminate at our favorite points, 2 times 3 pi over 8, which is 3 pi over 4, does terminate at one of our favorite 16 points, and we know the cosine of that to be negative radical 2 over 2. And that completes this problem.